All right, let's look at the rotation matrix. So we want to come up with a 2 by 2 matrix. If you multiply a vector by this matrix from the left, you're going to rotate that vector about the origin by theta counterclockwise. All right. So how do you find such a matrix? All right. So there's an easy way to find such a rotation matrix. All right. So we're gonna actually just try to apply that matrix to 1, comma 0 and 0, comma 1. Then we know exactly what full components are. All right. So let's do that. All right, so since we don't know what this is, I'm going to call this guy rotation matrix R theta. All right, I'm going to apply this to a point or a vector 1, comma 0. All right, which is this guy right here. All right. And we know exactly where it needs to go, right? Because we need to rotate counterclockwise by theta. So it's going to just, it's going to be rotated by theta. And you should end up going to that place, right? And we happen to know, since this is a unit circle, we happen to know the coordinates there, which is going to be a cosine of theta, comma, sine of theta. All right? So since we don't know our theta, so I'm going to just, for now, call this guy some matrix. So A, B, C, D. And we're going to apply that to 1, comma 0. Right? By applying a matrix multiplication, so A, B, 1, 0, so you're going to get just A, and C times 1 plus D times 0, so that's going to be C. So you can see that this just extracts the first column of the matrix, right? And I'm going to do the same thing to 0, comma 1, which is up here. All right, so I'm going to multiply R theta and by 0, comma 1. And so you have, I'm just going to write it, A, B, C, D. And you apply that to 0, comma 1. All right, and this is going to move to, you can see A times 0 plus B times 1, so that's going to be just B. C times 0 plus D times 1. All right, so if you multiply by 0, 0, 1, then you actually extract the second column of that matrix. All right, and we know exactly where these guys are going. So the first one, we know that this is going to go to, right, cosine of theta. So cosine of theta, comma, sine of theta. All right. What happens if you rotate this 0, comma 1? So it's gonna it's gonna go over there. So it's gonna rotate theta. All right, this point is going to be, all right, so this is a little tricky. So this is going to give you sine. So this is a sine of theta, but it's in the negative direction. So it's a negative sine of theta. All right, and this y coordinate is a cosine of theta. So you have a cosine of theta. All right, so this is going to go to negative sine of theta, cosine of theta. All right, but you can see that the first one is simply the first column of the rotation matrix, and the second one is the second column of the rotation matrix. So now we know a rotation matrix should look like cosine of theta, sine of theta, negative sine of theta, cosine of theta. All right. And this is called the rotation matrix. This will rotate about the origin by theta counterclockwise. All right. So there's an interesting application of this rotation matrix to prove trig identities. Right? You probably have seen these two identities, and cosine of a plus b and a sine of a plus b. You know, cosine goes cosine, cosine, sine, sine with a negative sign. Sine goes sine, cosine, cosine, sine. All right, probably in high school you try to memorize that, you know, by going over it over and over. All right, and we can actually prove this using a matrix multiplication. All right, so you can think of, yeah, let's look at the rotation matrix. So maybe I'll say proof. All right, so if you look at the rotation matrix by angle A plus B, right? And we know exactly what this look like, right? So angle is A plus B, so you have a cosine of A plus B, sine of A plus B, negative sine of A plus B, cosine of A plus B. All right. All right, this is one way to look at it. You rotate by angle A plus B. All right. But we can actually split this into a combination of two rotations. You can either rotate by A and then rotate by B. And a rotation you can actually apply in any order. I'm going to actually rotate it by B first, then rotate by A. All right, so here. So this is really the same thing as rotate by B and rotate by angle A. All right, so this is just a matrix multiplication, and the first guy is going to be cosine of A, sine of A, negative sine of A, cosine of A. So that's rotation by angle A. And the rotation by angle B would be cosine of B, sine of B, negative sine of B, cosine of B. Right? So those two rotations are exactly the same. You can rotate by A plus B, or you can rotate by A, or I should say rotate by B, then rotate by A. All right. But if you multiply these two matrices together, we're going to get, I'm going to just do the first column, right? So this times that gives you cosine of A times cosine of B minus sine of A and sine of B, right? And this times that gives you sine of A times, let's say, cosine of B plus cosine of A times sine of B. For this proof, I don't really need, I'm too lazy. So you're gonna have something here, and you're gonna have, that looks like 0. So maybe I'll just do this. You're gonna have something here. We're gonna have something here, right? But all I need is a correspondence. We know that this matrix and the first matrix are exactly the same. So we have cosine of A plus B is equaling cosine of A, cosine of B, minus sine of A, sine of B, which is the first identity here. And if you look at this correspondence, sine of A plus B is equal to sine of A cosine of B plus cosine of A sine of B, which is this second trig identity. All right, so we can use the rotation matrix to prove some trig identities. All right, that's it. I hope that this was clear.